At 2:30 p.m., the Ukrainian team launched their strike, but the Russians were ready. As the drone closed in, a deadly game of cat and mouse unfolded in the skies. The Ukrainian team expected to conduct a routine strike mission. Their Shark-D reconnaissance drone was already circling over a shattered bridge, a perfect choke point. The Russians had no choice but to pass through. Below it crawled a slow convoy, hauling a 152mm howitzer across twisted concrete. It looked like the kind of target drone operators dream about. But within minutes, the mood changed. The mission flipped. The drone that came to hunt suddenly became the thing being hunted. Every burst of video the Shark sent back was a beacon in the electromagnetic dark. With each transmission, it wasn't just sending images. It was also announcing its position to any listening device. And somewhere out there, something was listening. The Russian convoy continued inching toward the bridge at barely 15 kilometers an hour. Meanwhile, the Ukrainian strike team waited just 4 kilometers away. The only problem? 3 layers of Russian defenses stood between them and the perfect shot. At the center of that defensive web sat the Zoopark-1 radar. It was designed to track artillery shells in mid-flight, calculate where they came from, and direct counterfire at the launch point. The Russians realized that the drone signals were just another kind of radio emission. The method was brutally simple. The radar listened for a signal, took a bearing, and drew an invisible line pointing toward the source. 1 line meant nothing. 2 lines meant a guess. But 3 lines that crossed at the same point? That meant coordinates. And 3 minutes after those coordinates were confirmed, artillery would be arriving. Ukrainian teams knew the odds. Transmit from the same position for more than 5 minutes, and there was nearly a 50-50 chance the next sound you heard would be incoming rounds. So the Ukrainians adapted. They hopped through 128 different frequencies every second. They kept transmissions to tiny bursts, just 0.3 of a second, then 30 seconds of silence. Enough to fly the drone, but not long enough for the radar to nail them down. But things took a turn. Their thermal sensors picked up trouble. The Russian Orlan-10 drone was approaching from the north. That meant the Russians already suspected operators were nearby, and they had sent their own hunter into the sky. The Ukrainians had to choose: keep eyes on the convoy or go dark. They chose to hide, but before dropping off the grid, they needed to inform the strike team positioned 4 kilometers away. Normally, they'd hand off the target by direct radio, coordinates, timing, and approach vector. But that meant 2 units transmitting at once. Twice the signal, twice the danger. Instead, they pulled off something clever. The Shark dropped a digital breadcrumb, a tiny encrypted packet on an unexpected frequency, a frequency that the Russians weren't monitoring for drone control. In that brief blip, the strike team received everything they needed: exact convoy position, speed, wind direction, and recommended attack angle. The whole thing took 0.3 of a second. The strike team received it perfectly. By then, the convoy was halfway across the broken bridge, crawling past piles of concrete and twisted rebar. They had 10 minutes at most before they cleared the kill zone. At 2:45 p.m., the FPV operator powered up his drone. The machine was a 7-inch carbon fiber frame, a 2-kilogram shaped charge strapped underneath, and a fresh battery with just enough power for 7 minutes of flight. The convoy was 4 minutes away. On paper, it should have been easy. But Russian troops had learned an important truth. You didn't need to shoot a drone out of the sky. You just had to break the link between pilot and aircraft. No connection meant no control, and no control meant a crash. The first half of the flight went smoothly. The Ukrainian FPV skimmed low. The video feed was crisp and clear, but exactly 2 kilometers from the target, the screen flickered. Lines of static crawled across the picture. The frame rate dropped: 60 frames, 30, 15. The Russians had turned on their repellent-1 jammer. The jammer blasted out so much energy that it practically cooked every frequency around it. For the drone, it was like trying to whisper during a hurricane. The operator jumped to a lower frequency, something outside the usual jamming range. The picture came back, but barely. And this was only the first layer of defenses. The backup frequency barely held the video together, but still something the operator could work with. But as the drone closed to 1.5 kilometers from the target, even that signal started breaking apart. It was obvious now. The Russians had layered their defenses like armor. There was the big one, the high-power mounted jammer on the vehicle. Then, portable jammers were tucked into trenches every couple of 100 meters, and somewhere hidden among trees, an entire Pole 21 area denial system was broadcasting a wide blanket of interference. 3 separate systems overlapping their frequencies, creating an electronic dead zone where signals went to die. But unlike a real black hole, the Ukrainians had a way to claw their way through. The FPV drone carried an onboard AI module trained on 10,000 hours of real combat footage. It could recognize vehicles, lock onto them, and guide itself in those final moments without pilot input. The catch? It needed a clean, unobstructed view of the target for a full 2 seconds to lock on, and the lock could only happen from about 400 meters out. So the operator was flying blind through more than half a kilometer of pure electronic chaos, hoping to reach that magic range before the drone lost all power or control. There was no video, no visuals, just raw instrument data. The compass bearing was 73 degrees, with an altitude of 3 meters at a speed of 45 kilometers per hour. He kept the drone low and slow. At this point, saving battery mattered more than speed. Then something unexpected happened. At a little over 3 kilometers from the bridge, the video feed blinked back to life for a single frame. Literally 1/60th of a second. But that was all he needed. In that ghost of an image, he caught the silhouette of the bridge, maybe 800 meters ahead. And the truck was exactly where his calculations predicted it would be. Then the signal vanished again, but that one frame confirmed he was still on course. He pushed on for another 400 meters of blind flying, and the AI could, if everything went right, take over. Then, suddenly, the screen cleared. Crystal clear video for a full 2 seconds. The jamming wasn't perfect. Maybe the repellent one had rotated its antenna array, or maybe the metal structure of the collapsed bridge created interference shadows. A Russian interceptor drone was already diving toward him from 20 meters up. The thing came down at a 45-degree angle, like a hunting falcon cutting through the air toward a pigeon. Both drones were nearly identical. 7-inch frames, 4 motors, lightweight, fast. But the interceptor had one massive advantage: altitude. The Russian pilot could convert altitude into speed, acceleration, and everything he needed to get the kill. Drone-on-drone combat is brutally fast, with both aircraft closing on each other at nearly 280 kilometers an hour and only about 300 meters between them. The operator had less than 4 seconds to react. To make things worse, the Ukrainian drone carried a 2-kilogram shaped charge strapped underneath. In a dogfight, it was like trying to box while wearing a backpack full of bricks. Every maneuver drained more energy. Every turn took longer to complete. The Ukrainian operator yanked the stick left, hard. The drone banked at a sharp angle, groaning under the 5 Gs of force. Motors screamed unevenly. Left pair throttled down. Right pair slammed to max, forcing the drone into a tight arc. At that speed, it carved an 89-meter turn radius, barely enough to dodge the interceptor's first strike. The Russian drones shot past, forced to overshoot and loop around for another attack. But now, the fight became a game of energy management. Hard turns drained battery life at nearly 3 times the normal rate. The drone's voltage dipped fast: 15.2, 14.9, 14.8, falling by nearly half a volt in just 10 seconds of evasive flying. At this pace, the battery would die before the drone even reached the bridge. The Russian pilot realized that too, so he changed tactics. Instead of chasing horizontally, he pulled upward, gaining altitude. He'd dive again, but this time with even greater speed, using gravity to boost himself beyond the drone's ability to dodge. The Ukrainian drone couldn't climb, not with that heavy warhead, not with that sagging battery. Trying to match the Russians' altitude was impossible. So the operator did something completely counterintuitive. He cut the throttle and just dropped it. The drone fell like a stone, plunging from 15 meters down to 3 in barely 2 seconds. It practically disappeared from the interceptor's targeting path. The Russian dove hard, expecting to hit the Ukrainian drone mid-air, but instead sliced through space where the target should have been. The drop saved the drone, but it came with consequences. Cutting the throttle meant cutting lift. With no power pushing the props, the drone became a falling brick. For a moment, it wasn't flying at all. It was just dropping. The Ukrainian operator jammed the throttle back on, and the drone barely caught itself above the ground. But the danger wasn't over. The Russian pilot recovered fast and banked into another turn, preparing a second dive, this one even faster than the first, and the Ukrainian drone had almost no energy left to maneuver, and it still had to make it through the last 400 meters of jamming. Everything now came down to the next 3 seconds. For 2 full seconds, the drone fell like a dead weight, nothing but gravity taking over. He had one chance to save it, but he had to bring the power back gently. If he slammed the throttle, the torque would flip the drone clean over. If he brought in too little, it would hit the ground before it ever recovered. He eased in 30% power. The drone steadied at barely 3 meters above the ground. It wobbled wildly, the flight controller fighting to claw back authority after being pushed to the edge of aerodynamic stall. But it held. Above, the Russian interceptor pulled out of its dive, bleeding speed as it climbed. For a moment, both machines sat in the same fragile state. Low altitude, modest speed, batteries draining far too fast. They circled each other like two boxers trying to read their opponent's rhythm, looking for that one opening to end things. And now, the weight difference finally came into play. The Russian drone, carrying no warhead, had a better power-to-weight ratio. It accelerated faster, climbed quicker, and could snap into a stop in half the distance. In tight turns, it pulled 6 Gs without complaint. The Ukrainian drone, weighed down by its explosive charge, could barely handle 4.5 before the flight controller hit its limits. Every reversal brought the Russian drone a few degrees farther into its blind spot, exactly where the camera couldn't see. The Ukrainian operator had one move left, one they trained for but rarely used: a vertical reversal. He punched full throttle. The drone shot upward at 10 meters per second. All its forward speed drained away as it climbed. The Russian operator followed, expecting an easy finish. But at the top of the climb, just as the Ukrainian drone hung motionless for a split second, the operator cut the throttle again and snapped full yaw. The drone spun 180 degrees so fast it looked like a trick shot. Now its nose was pointed straight down, right at the Russian interceptor clawing upward. A head-on collision was almost certain. The Russian pilot committed to it. This was his job. His drone was expendable, and taking out an enemy warhead was worth the sacrifice. But at the very last moment, the Ukrainian operator rolled hard right while maintaining the dive. The Russian platform blew past, slicing through empty air where the Ukrainian drone had been a heartbeat earlier. By the time the Russian operator corrected the climb and tried to reacquire, it was too late. The Ukrainian drone was already leveling out low, 5 meters above the ground, and racing toward the bridge again. The entire dogfight had lasted 18 seconds, and just surviving that had eaten 30% of the charge. The readout showed 14.5 volts, only 8% of capacity left, but the target was finally closed. The Russian truck was 3/4 of the way over the bridge now. 3 soldiers waited ahead, already braced and armed. They knew exactly what was coming. The first soldier reacted instantly. His AK-74 barked out tight bursts. He led the drone like a hunter, tracking a fast-moving bird. The 5.45mm round punched through the carbon frame, severing the power leads to the rear left motor. The drone lurched violently. The flight controller fought back, recalculating thousands of times every second. But physics was physics. 3 motors meant 1/4 of the thrust was gone. No matter what the operator did, the drone kept sliding left. At 35 meters, the shotgunner stepped in, a Saiga 12 loaded with buckshot, 65 pellets spreading into a 15-meter wide cloud by the time they reached their mark. The drone was moving at full speed, 140 kilometers per hour. It would cross the kill zone in half a second. The shotgun boomed. Most pellets missed, 2 didn't. One shredded the right front motor. The other punched through the battery casing. Voltage plummeted, 14.5, 13.8, 13.2. Within 2 seconds, the drone was dying mid-flight. Speed fell to 80 kilometers per hour. The AI struggled to keep a lock on the truck, its red targeting outline flickering as distortion corrupted the feed. 20 meters out, the second shotgunner fired, but physics finally gave the Ukrainian drone a break. With 2 motors gone, it dropped 2 meters unexpectedly, and the buckshot cloud hissed overhead. The soldier racked another round, but the drone screamed past him before he could fire again. 15 meters. The third soldier, positioned near the cab, tried to bring his weapon to bear, but he discovered he couldn't angle it downward enough. The drone was skimming at barely 1.5 meters, too low for him to track. He stepped back to adjust, but tripped. 10 meters. The AI made its final choice. The operator wanted the cab, hit the ammunition, and destroyed everything. The battery fell to 12.8 volts, below the safe threshold. Thrust hovered at 40% and was fading. 5 meters. The drone hit slower than ideal, just over 60 kilometers per hour, but it didn't matter. The shaped copper jet punched straight into the ammunition compartment. 8 152mm artillery shells cooked off at once. The explosion lifted the truck clean 2 meters into the air. The bridge deck cracked under the overpressure. The truck and its artillery piece tipped sideways and slid off the broken span, tumbling into the river below. Overhead, the Shark-D reconnaissance drone captured everything in razor clarity: the destroyed convoy, the collapsing bridge, and the soldiers staring in disbelief as smoke rose hundreds of meters into the sky. Target eliminated. The Ukrainians had pulled off an impossible strike, but the war rages on. What happens next? Let us know in the comments below. Subscribe for more real-life war stories and drone warfare analysis.